Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this is for the course of SMS 1034, and it is a continuation from the first chapter related to probability, and specifically this video for topic Bayes Theorem. So first of all, let me just give you some introduction about Bayes Theorem. So this is Bayes rule. So the Bayes Theorem was developed and named for Thomas Bayes, 1702 to 1761, and then it showed the relation between one conditional probability and its inverse, and it provides a mathematical rule for revisiting an estimate or forecast in light of experience and observation. So basically, the concept that we use in this Bayes theorem using the concept of conditional probability. Okay, so you may look back in chapter 1 under the topic or subtopic of conditional probability. By definition, Bayes theorem is a method of revising a probability given that additional information is obtained. So what is the formula of Bayes theorem? So basically, the formula of Bayes theorem comes from the conditional probability formula and also the multiplicative law of an dependent event. So first of all, let me show you here how you come up with the Bayes theorem. So remember the concept of conditional probability previously. Firstly, if you can remember, the formula for conditional probability is PA given B equal to PA intersect with B divided by PB. And if you can see here, if you move this denominator to this left hand side, so it's become like this, in which PA intersect with B equal to PA given B times PB. Okay, you just move this denominator here. Then, this is the first case if you want to find PA given B. How about PB given A? So, if you want to find PB given A, similar concept using conditional probability is you just use PB given A equal to PB intersect with A divided by PA. So, if you can see here, the numerator here, PA given B and PB given A is actually exactly the same, or is a vice versa. So, basically here, the numerator PB intersect with A here is actually PA intersect with B. That's why it is actually can be written as PB given A times PA. So I can move this and I substitute here. Okay, I move this PB given A times PA and I substitute here with the understanding that PA intersect with B is actually equal to PB intersect with A. So this conditional probability will becomes Bayes theorem, in which PA given B is equal to PB given A times PA divided by PB. So this is basically the Bayes theorem and the formula that will be used in this topic. Alright, so PA given B equal to PB given A times PA divided by PB. In probability theory and statistics, Bayes theorem, which also known as Bayes law or Bayes rule, describe the probability of an event based on conditions that might be related to the event. Okay, some pronouns as Bayes, some pronouns as Bayes. Right. Another term in Bayesian study is Bayesian inference. Bayesian inference is a method of statistical inference in which Bayes theorem is used to update the probability of a hypothesis as evidence. So in Bayes inference, it involves prior probability. This is the first term. When you say about Bayesian, you must kind of familiar with this term, which is prior probability, which is the initial probability based on the present level of information. Okay, based on present level of information. And also posterior probability, which is a revised probability based on additional information. So when you relate to Bayes theorem, so these two terms, at least you must aware of it. So let's look back at the Bayes theorem or the formula PA given B equal to PB given A times PA over PV. Okay, so from this formula, we can see that we have here PA and PB. PA and PB are the probability of A and B without regard to each other. they are independent. So we call this as a prior probability. Okay, and then we have PA given B. This part, it is the probability of observing A given that B is true. So we call this as a posterior probability. And then we have this probability, which is PB given A. It is the probability of observing event A given that A is true. It is called a conditional probability, or also known as a likelihood. So that's the term in the Bayes theorem for the formula. So basically, for the topic of Bayes theorem, there are several basic probability formula that will be used. So the first one is basically the product rule, the one that I showed you just now, in which PA intersect with B, or PA and B is equal to PA given B times PB, or PB given A times PA. And then we have sum rule or addition rule, PA union B or PA or B equal to PA plus PB minus PA intersect with B, or PA and B. And then Bayes theorem, the one that I showed you just now, PA given B equal to PB given A times PA divided by PB. And then when we have this Bayes theorem, see the denominator here. So here we need to use theorem of total probability. Okay, total probability with the assumption that event AI is mutually exclusive and the sum is equal to 1. So every time you want to find the denominator here, you need to use this theorem of total probability. So what is the formula? Is this one, PB equal to summation of PB given AI multiplied with PAI. If you have more than one event, you might use PB equal to PB given A1 times PA1 plus PB given A2 times PA2 plus, and so on and so forth. That's the theorem of total probability. Okay, this is the one that I told you just now about. If you have more than two events, it will look like this. Okay, so let's look to the example to make you more understand about this theorem. Okay, suppose that you are given the data 1% of women at age 40 who participate in routine screening have breast cancer. So 1% of women have breast cancer. Okay, this is all the information given, and 80% of women with breast cancer will get positive mammography. Okay, what else? 9.6% of women without breast cancer will also get positive mammography. So for this case, actually, a woman in this age group had a positive mammography in routine screening. What is the probability that she actually has breast cancer? So the question is, what is the probability that she actually has breast cancer given that she had a positive mammography? Okay, she had a positive mammography. So I will just show you the solution for this example in two situations. First, we try to solve it without Bayes theorem, and then I'll show you how to solve it using Bayes theorem. Okay, so in order to solve this without Bayes theorem, so basically we kind of need to create a large sample size, and we use the probability or the percentage given in the question to kind of to work out the problem, because we don't have data but we have percent. So we need to assume, for instance, for this case, we assume, for example, that there are 10,000 women participate in a routine screening for breast cancer, in which 1% from these 10,000 women have breast cancer. 1% from 10,000 is 100. Okay, what else information? Next, 80% of women with breast cancer. Okay, 80% of women with breast cancer. For this case, women with breast cancer is 100. So 80% means 80 women. Okay, we'll get positive mammography. And then the next information is 9.6% of the women who don't have breast cancer. 9.6% from 10,000 minus 100, which is 9,900 women. When you calculate 9.6% out of 9900, we'll get 950 women who don't have breast cancer will also get positive mammography. So this is the situation when you solve it without Bayes theorem, kind of we need to let the number of women 10,000. Then, to make more understanding about this data, we may tabulate the data in order to find the answer. So this demonstration just to show you the step how to solve it if you don't know Bayes theorem. Okay, so basically what I want you to learn here is basically how to use the formula for Bayes theorem without you assuming the population. Okay, so but just continue about this example without Bayes theorem. So basically from the data we got just now, first we assume that there are 10,000 number of women in which 1% have breast cancer, which is 100 women, and then of course when this is 100, okay, the rest will be 9,900 women without breast cancer. And from the question, 80% of women with breast cancer have positive mammography, so it is 80 women, in which the rest will be 20 women with negative mammography. Then we have 9.6% of those without breast cancer have positive mammography, and the balance will be 8950. And this is the total with negative mammography, and this is total of women with positive mammography. So we have all the information here. So basically, the question asks you to find probability of women with breast cancer given that they have positive mammography. So out of those who have positive mammography, 1030, how many of them have breast cancer? 80. So basically, the probability will be 80 divided by 1030. 80 divided by 1030, which is 7.767% or 0.0776. Okay, so this is if you need to answer the question or find the solution using without Bayes theorem. Means you need to kind of assume certain number of human. Okay, so next I will show you how to solve this using Bayes theorem. Okay, we have these three information from the question just now. 1% of women at age 40 who participate in routine screen have breast cancer. So we let the probability be for women who have breast cancer as 1% or 0.01. And then 80% of women with breast cancer will get positive mammography. P positive mean probability of positive mammography given that they have breast cancer 0.8. And then 9.6% of women without breast cancer will also get positive mammography. Okay, probability of women who positive given that B prime here represent without breast cancer, the probability is 0.096. Okay, when you are using Bayes theorem, basically they will use figure of probability from 0 to 1. So all the probability, remember in the first chapter we learned it must be between 0 and 1. Okay, so the question is, what is the probability that she actually has breast cancer? PB given positive. So this is the one that you want to find. Okay, first of all, of course, you need to relate with the formula of Bayes theorem. Okay, so this is the formula of Bayes theorem. Of course, not necessarily you use plus here for positive. You may change it as P or whatever later that easiest for you to understand this, the situation. So here we use B for breast cancer, B prime for without breast cancer, and positive represent positive mammography. Okay, so here PB given positive is equal to P positive given B times PB divided by P positive. Okay, so from here, so basically we have information of probability of breast cancer. From the woman with breast cancer, we have the information. And we also have information about probability of those women who are positive, who had the positive mammography given that that woman have breast cancer. And we have the information of probability of plus or positive given B prime. Positive mammography among those without breast cancer. So we have these three information. We have PB, we have P positive given B, but we don't know what is PB. P plus or P positive. So this is the one that we need to find first, the denominator here, before we can calculate PB given positive. Right? So remember this total probability, the rule of total probability, P positive is basically P positive given B times PB plus P positive given P prime times PB prime. Okay, so when they ask you to find total probability of those women who have positive mammography, means both population, women with positive mammography and have breast cancer, plus women with positive mammography without breast cancer. So remember, this one is basically probability of mammography and breast cancer, probability of without breast cancer and positive mammography. So this is for the total. Right, so you calculate P positive, then you get 0.1030. So basically you have all the information here, so you just substitute the value, and then you got this PB given positive, or probability of women with breast cancer given that they had a positive mammography. So as you can see here, we have 0.07767, and if you convert it to percent, you will get 7.767%, which is exactly the same which the one that we assume 10,000 women just now. Okay, so this is how you calculate. So basically in Bayes theorem, you need to understand all this information in order for you to get the answer. Alright, so this part is very important, and this part in identifying all the information given in the question. Of course, it needs practice. Okay, why not we go to the next example. Okay, example 2, given a data like this, you have mode of transport, probability if he is late. So here is Bob. This is probability Bob is late. So for instance, you have mode of transport if by car, the probability that Bob will late is 50% or 0.5. And we have if by bus, the probability that Bob will be late is 0.2 or 20%. And if Bob come to the office or come to work by train, he will be late. The probability that he will be late is 1% or 0.01%. Okay, so the question is, suppose that Bob is late one day. His boss wished to estimate the probability that he traveled to work that day by car. So please understand this question. So basically, his boss wished to estimate the probability that he traveled to work that day by car, given that on that day he is late because of this statement. So what you want to find here is basically probability of car given late. Okay, probability of car given late. So you have the information here. This is the information of probability of late, isn't it? So it's become probability of late given car 50%, probability of late given bus 20%, probability of late given train is 1%. And then what else information given? So for this question, he does not know which mode of transportation Bob usually use. So he gave a prior probability of 1 in 3 to each of the 3 possibility. So since the boss don't know what is the mode of transportation that Bob usually use, so he gave prior probability. Remember the prior probability that I told you just now? It is the individual probability. So for this case, he gave 1 over 3. 1 in 3 means 1 over 3 or 0.33. So basically, probability Bob will take car or use car or travel by car is P car equal to 0.33. Probability of bus or probability of he will travel by bus 0.33, and probability of he will travel by train is also 0.33. So first of all, you need to kind of take out all the information and try to fit in the Bayes theorem formula. Okay, so let me just show you how to solve this. Okay. Okay, so remember just now we have information on PC, which is P car. This is the given prior probability, P car, P bus. You're not necessary to use bus car. You can just change it with any other letter, PC, PB, whatever you like, as long as you understand. P train is equal to 1/3 or 0.33. So this is information given in the question. And also you have information on P lead given car is 50% or 0.5, and we have P lead given bus 0.2, and we have information P lead given train 0.01. This is all information given from the question. So what is actually you want to find? So based on the question, you want to find probability of probability of car. So the boss want to check probability of car. He traveled by car, and that day they bob late. Okay, so basically probability of car late. This is the one that you want to find. Okay, so what is the formula? First of all, of course, you need to kind of write down the formula so that you get the understanding what is the information that you miss. So P car given late is actually by using Bayes theorem is P late given car times P car divided by it's difficult when you write down and you didn't actually see the line. Okay, but anyway, so this is P. Just try to slowly. Okay, so divided by P L. Okay, so look at the information here. You have information P lead car here. This is information for lead, like P lead car, and we have information of P car, which is this one. The only information that you don't have is this one, PL. Alright, so how to find PL? So basically, remember the total probability rule. PL is actually in sentence is basically probability of lead and car plus probability of lead and a bus plus probability of lead and train. Okay, so the formula will be P L given C times PC plus PL given B plus times let me just delete it. Okay, PB plus PL given train times P train. So all this, the information are given. So PL given C times PC. PL given C is 0.5 times 0.33 plus 0.2 times 0.33 plus 0.01 times 0.33, and here when you calculate, you got the figure here. Okay, so from here, then you can solve it just substitute the information. Late given car is 0.5 times P car is 0.33, and you divide it by this figure. What is this figure? Okay, let me just calculate this. 0.5 times 0.33 plus 0.2 times 0.33 plus 0.01 times 0.33, which is equal to 0.2343. So 0.2343. So you substitute here. Okay, then you just using calculator substitute, then you got the answer. So this is the how you answer the question. So it depends on the the question. And normally when you are given a question, they have all the information, and at the end they will ask you what is the probability. So that part you need to kind of really understand what the question basically want. Okay, so let me just go back to the slide. Okay, so remember this is all the information given for the one that I showed just now. All the slide has been uploaded in my group, so you may download and look at it again. So this is basically the solution, the one that I showed you just now. So this is the one. So P car given late is actually P late given car times P car over P late. We know that all these are information given. P car equal to P bus equal to P train 0.33, P late given car 0.5, P late given bus 0.2, P late given train equal to 0.01. And here, as I mentioned just now, we need to find P late, the denominator here. So this is the formula: P late given car, P car, plus P late given bus, P bus, plus P late given train, P train, and you got 0.2343. And then you substitute all these into the formula, then you got 0.7042. So how to interpret this? So if you use percent, so basically you may say that there are 70.42% that Bob will late. If he travel by car, he will be late. Okay, on that day, if he travel by car, he will be late. The percentage is 70.42. Okay, so I think that's enough for two examples. As usual for this course, the attendance will be based on your participation on tasks at the comment below and in this YouTube. So as usual, I need you all to answer this. Write down your name, your metric number, and group C, and give me the link of the answer. Okay, give me the link of your answer for this task. Okay, so feel free to ask any question in our WhatsApp group. Okay, only if you ask, then I will understand what is your problem. Don't tell me that you don't understand from the beginning. So please, so it's actually part of chapter 1, only chapter 1. So please ask if you don't understand. And if you can check in our assignment platform, so there will be assignment 1, individual assignment, and there is a question about Bayes theorem. So basically, you can answer that assignment, you do it, and you may submit when you're done. Okay, so remember, so this is the task. All the best. Assalamualaikum.